Everyone. Good night. I'm sorry, good morning, good afternoon, good night. So welcome to our webinar. Let's just wait for a few minutes. So we will starting soon. Thank you.
Welcome everyone. Thanks for joining our webinar on Unleash the Power of Precision with LiDAR Topographic series, presented by DJI Enterprise. My name is Brad Lee. I'm from DJI Enterprise Solution Engineer team, and I will be your host. During today's webinar, we will discover how LiDAR is revolutionizing topographic surveys across construction, environmental, and urban planning projects, featuring insights from geomatics. Learn to harness high-resolution drone image, extensive point cloud data, and detailed DEM to boost precision and success in your projects. Today, our presenter includes Izzat Sabri, founder and managing director of Geomatics Integrated Solutions, and me, Brad Lee, solution engineer for Geospatial from DJI Enterprise. Today, Izzat will begin his presentation at LiDAR Topographic series, includes project description, output sample, fieldwork preparation and execution, and data processing. Then I will go over the L2 introduction, post-processing software, and share some case studies. The last part will be the Q&A section. If you have any questions during the webinar, please feel free to click the chat button on the left to leave your comments. After the introduction, we will answer your questions live. Well, at this point, I'd like to turn things to Mr. Izzat to learn more about how to use DJI Zenmuse L2 to finish a 100 square kilometers project. Take it away, Izzat.
Thank you, Brad, for the introduction. Hello, everyone. It's my pleasure to be your host today for this interesting webinar and interesting project. Our scope today is to show not only how to use LiDAR in such different industry or application, but also to show how can we reach precision results for a larger area using an affordable sensor like L1 or of course L2. My name is Izzat Sabri. I'm Managing Director of Geomatics and I'm a surveying engineer. I'm having more than 18 years experience in remote sensing, advanced and high definition mapping through using laser scanning and photogrammetry. On the other side, I'm very glad to host this webinar with Bradley, as we are partnering with DJI maybe since for more than 8 years now, since 2017. We sold maybe more than 80 to 90% of drones in the Egyptian market, and now we are gold channel partner in Saudi. Please mute your microphones if you have them on. On the other side, we will be glad to answer your questions, so please feel free to drop them in the Q&A box, and we will be answering them at the end of the session. The outline is simply going through the introduction, project description, also output sample, in addition of preparation and execution field work planning, and at the end we will be showing the data processing stages and of course the end result. Geomatics is Geointelligence System Integrator in MENA region. We are the first in Egypt specialized in reality modeling and digital twins. We integrate digital technologies across the design, build, operate life cycle to improve management of assets. And after Egypt now, we have our separate Saudi entity in Kingdom of Saudi Arabia, and also we are serving MENA region with different technologies. Of course, today's challenge is how to create a digital twin. Even for a brown field or a green field. And surveying engineers now became data managers, not data collectors, because remote sensing and remote sensors and big data and gigantic data sets we are extracting from field each day need to be managed, manipulated by AI protocols or algorithms, and at the end utilized across different stakeholders. So this is exactly what we do. We do this with the help of DJI Enterprise, our oldest partner, also Israel. We are bronze partner in Israel, in Egypt, and also in Saudi. We are representing Bentley Systems for more than 7 years in Egypt and also in Saudi and United Arab Emirates. Maybe we sold the quantum systems, the Trinity serial number 009 in 2017. We are proud also to be a partner to the best fixed wing system in the market. Of course, Zora and Flores, they are the best 3D laser scanning, terrestrial laser scanning systems. Yellowscan, the best LiDAR. Flying Cam is a very serious platform when you have when you care about your airborne heavy lifting unmanned air vehicles for payloads up to 10 kilograms. Also, the best of the Swiss geospatial industry picks 4D and flyability. When it comes to metric camera or medium format camera, we have Hasselblad and Phase 1. Also, Matterport for affordable and non-engineering digital twins. But of course, you can export them to Autodesk. Share UAV if you want an oblique camera, and also we are partnering with MicaSense when it comes to the best multispectral analysis for agriculture. When you need to analyze your point cloud and generate as-built using AI, TerraSolid and ClearEdge are the best. And finally, Altea, which was a part of DeLair, which they have the best AI platform for different applications as a service. So now for our project, it was a gigantic petrochemical project, which will be built on a footprint of 5 square kilometers on the shore line of the famous Suez Canal. Before starting of construction in this 20 billion facility, there was a big need for understanding more about the nature. If there is any tectonic layers below the ground which could have any negative effect in the future, if there is any risk from the flood. So the owner started to make some futuristic and advanced studies for geotechnical surveying and also for LiDAR topographic survey. This area seems to be normal area, but the LiDAR survey was needed to be done for 100 square kilometers, which is 10 kilometers by 10 kilometers. This is a mining area, an abandoned mining area with different in elevation, more than 300 meters in less than 1 kilometer. Also here we are having a cement factory. Here one of the biggest steel factories in Egypt. Also here an industrial area with different facilities working with different circumstances. Here we can find a water treatment station. Here we can find a power station. There are more than 85 power line and pylon, some of them exceeding the flying altitude. Also, we can see Siemens fast trail track is here. Also, a high-speed road, in addition of a very, very harsh terrain without network coverage. This area is not challenging us by its large scale, but also the diversity of the assets and the different artificial and normal circumstances was very hard for us. That's why we started to take different approach. The following was required by the client: LiDAR survey, Land XML, high resolution drone imagery, point cloud data, ground extracted point cloud data, and digital elevation model. انا عادل صبري، مانجنج دايركتور جيوماتكس وبروجكت دايركتور للمشروع اللي هنتكلم عليه النهارده. المشروع ده يمكن اول مره يتعمل باستخدام تكنولوجيا الليزر من طياره بدون طيار في مصر. المشروع يعتبر سكيل كبير، المشروع 100 كيلومتر مربع، معمول علشان دراسه سيول لمجمع بتروكيماويات. تكنولوجيا الليزر تعتبر مختلفه عن التصوير الجوي، بتحتاج ان احنا نطير على ارتفاعات منخفضه توصل ل 50 متر، فده يحتاج ان كل كيلو من 100 كيلو كان ليه خطه طيران منفصله. وقدرنا ان احنا ننشئ خريطه نظم معلومات جغرافيه نستخدمها اثناء التحرك جوه المشروع. استخدمنا DJI L2 دوت اللايدار اللي كان مكافئ للدقه اللي محتاجها المشروع. استخدمنا طياره مافا 3 انتربرايز، ودي احدث طياره من DJI. قدرنا ان احنا نعدي من مشروع زي دوت بنجاح الحمد لله.
انا ميرات ويلسون، انا I'm responsible for the marketing في جيوماتكس. احنا mainly المشروع ده كنا بنشتغل فيه كمساحه، واحنا استخدمنا اللايدار تكنولوجي. احنا بنستخدمها للكونستراكشن، نقدر نستخدمها للاجريكلتشر، للمايننج. وكون انه احنا من اوائل الشركات اللي استخدمنا اللايدار في مصر، احنا كجيوماتكس بنستخدم تكنولوجيز جديده ومختلفه، واهم حاجه ان هي تبقى بتسيرف ماركت وتكون دي حاجه مطلوبه over the global market.
So sorry for the Arabic speaking in the video, but we are not only directing our service to Middle East. We are happy to help anyone all over the globe, and every and each word which was told in this video will be mentioned in the presentation. And also I would like to thank Geomatics team whom helped me to get this project done successfully. So the area is 100 square kilometers. There is a lot of unknowns which cause problems during the field execution. Solution was needed to ease the geographical communication between field teams and also provide the project manager with the all needed information for efficient decision making. So I decided to split this project to 100 projects. Each project have a separate project plan, a separate equipment, a separate setup, a separate team, a separate weather conditions, and a separate altitude. Because each 1 kilometer, 1 kilometer in LiDAR is a big project, not a small project, by the way. But to be able to do it with a consistent point cloud density and also consistent accuracy and precision, this had to be done in a special way. We had 2 lines from the landlord, 2 points, which one baseline, GPS point number 2 and GPS point number 6. We had to generate 4 different points and connect them with those 2 points. And to do this, we used precise leveling. And our surveying colleagues attending this webinar know how hard this to achieve, and we had to do this because we wanted to use any of those 6 points as a base station while we are flying. So when you fly photogrammetry or LiDAR, you need to work on PPK or RTK, and you are having a base and a rover. The rover is a drone, and the base must be sitting on a known point. And we need the same accuracy for the 100 projects we have, and we cannot fly plot number 100 from base from station number 2, because here the baseline will exceed 5 kilometers, and the accuracy and the absolute accuracy will deteriorate. So we had to have more points into the corners. They should have been a little bit in the middle, okay, not to the corner like this, but it was sufficient. At the end, any baseline between the base and the drone in any plot was less than 2 to 3 kilometers. Also, we did a very important step before flying. We have permit to fly, but we must let each and every facility or factory or even authority that we will be flying. So we started to understand more about the neighbor area in the first week before even testing or flying, and we informed them that we'll be flying on a relative low altitude. The power lines also were very challenging because to get the most accurate results of DJI L1, we had to fly relatively low, below 70 meters sometimes, and most of those power lines are more than 70 meters. So we needed to understand in each plot, which already include power line, that it will have a separate setup, and we will be using RTK not only to get surveying grade accuracy, but also to prevent the drone from being attracted by the electromagnetic field of the pylon or the power lines, especially the high voltage power lines. So we used M3E or Mavic 3 Enterprise. It was a very new drone then, and it was the only drone which can also resist interference of connection, because it's not only running on 2.4 and 5.8, only it was running on 5.1 gigahertz. And also it had the RTK capabilities. It was the first Mavic with RTK capabilities when you add the RTK module. So it was a perfect tool to measure the power line height. So we use the drone to measure the power line height at the base, from the baseline from each power line, because you might be deceived by a difference of 10 meters and then at the end crash your drone and make a little disaster in the field. Also, we used our vehicles in the preparation of the project to understand more about the paved areas, the non-paved areas. How can we navigate, and how can we go through the hard terrain, and also we don't have network. So we used walkie-talkies, but before this, our professional rally drivers from Egypt, we helped us, because we knew that to be able to get this mission in a safe way, we had to make use of professionals. And Amin Shafii did it amazingly. Also, we started to select which areas are preferably will be used as base point for daily flights, because of we need electricity, we need shaded area, we need water, we need also to fly from safe places. By the way, this project was done during August 2023. So from the 1st of August until 31st of August, those were the 4 weeks, and it was too hot. Also, the steel factory here was increasing the temperature of the whole area. Here comes the interesting point of the ground control points array. Because we divided the project into 100 projects, we need to stitch them back together to one big project. And also, the client wanted the data to be projected on the Egyptian Transfers Mercator and use EGM 96. So we had to work with the Egyptian Surveying Authority and connect to their course network to process those ground control points. And I decided to put them after the first 2 plots. We were putting them scattered inside the plot, but then we decided no, we will be putting them evenly on the lines, and we will be making like 50 to 100 meter overlap between each plot and each plot. And this ground control point will be sitting in the middle of 2 plots. We are very delighted to announce that this was a key success in this project, and we are gladly showing we are not service provider, we support our customers. Even this project was support for the Egyptian government to do this, and we are gladly able to support even customers whom didn't buy equipment from us. That's why we are showing off this project and giving you the details of the know-how even. Also from the kitchen, maybe my team were not very happy for me to be sharing this, but we to be able to navigate through this very hard terrain and to make use of those data layers we created before the project, we started to use a field operation dashboard from the office. So each one of us have mobile application with a field data collector, and he is enriching the system with data, and also he is using the data from the GIS system to navigate. So which plots am I going to fly tomorrow? Which plots am I going to refly? Because sometimes we are reflying because of a mistake happened. We are not happy with the overlap. There was divergence. We need to make a terrain follow because there is difference in the density, or there is a high elevation difference between the beginning and the end of the plot. So it needs to be reflew. So from here, from this dashboard, we know how many targets are there, how many targets are we need to put tomorrow for the flying team to be productive. Are we behind the schedule? What should we do? What did we did wrong? What are we doing well to make sure that we are meeting the deadline? And after initiating this database, we started to use it through a field mobile app. Each one of us have his mobile. He is being traced by his mobile and sharing his location, okay, because we need to know who is where. And also he can open different data layers, like when you open your Google map and navigate between the image and satellite image, you can navigate between the base point, the takeoff landing spots, the targets, the roads, which plot are you there, also the facilities, the power lines, to be able to plan and avoid and navigate. Before flying, we had a hard choice. The project specs was from 5 to 10 centimeters. That's why I started to put the L1 into the competition with the other sensor I had in hand, which was the Regal Vux 1 from the legacy manufacturer of LiDAR. They have the best laser scanners in the market with precision up to 6 millimeters, and also in the survey grade you can fly up to 550 meters. But why did I choose the L1? We chose the L1 because why not? It can do the job. It is within the same range of the accuracy of the client requirements, which is very good for the application, because we as a surveyor sometimes are very obsessed by the best of the best. I want to get the sub-millimeter accuracy. I want to get the best density. I want to get the best. And at the end, I don't have the time. I don't have even the money. And I don't need it for my application. So please always select the right tool for the right application. And because with P1, we can achieve at 100 meters, 1.25 centimeters. There is a ground sampling distance. This have nothing to do with the accuracy. The JSD is something, and the relative accuracy is something, and the absolute accuracy is another issue, and we can go deeply more. Maybe Brad could tell us more about this. But again, compared to L1 with 5 to 10 centimeters, it might to be seen it's not accurate. No, but it is. It is a LiDAR sensor. It's not a photogrammetry sensor. And why did we use LiDAR? Because we need to extract all the features from the ground, which was done through DJI Terra, as we will see. And that's why you cannot do this with photogrammetry. That's why we went to the LiDAR. So to use a LiDAR, you even if there is height difference in the 5 or 10 centimeters, it doesn't matter, because I need the LiDAR because of its functionality, not the accuracy itself. But again, because the accuracy had the limitations, and we selected the L1 because it is falling within the same accuracy tolerance, we had to accommodate its capabilities, and that's why we started to make 100 kilometers. That's why we had to fly relatively low, because this is to get this surveying grade, which is relative again, because sometimes surveying grade is millimeter, sometimes is decimeter according to your application. You cannot fly the 450 meters. You can fly them if you are in a rescue mission and you want to know more details about where the lost people are. But this is a surveying mission, so to get the surveying grade, you must fly between 50 and 100 meters. That's why we were flying around 70 meters. And by the way, this is a very, very, very low altitude. We used M300. Also, we used DJI L1 because DJI L2 was not launched yet. It was launched in the next month in Intergeo 2023. So when I was very happy with this project, L2 came. And and Brad will show us how can L2 could have saved a lot of time and also provided better, not only accuracy, but even the camera and the shutter speed are much, much better. But we did it well with the L1. Also, we used Leica GNSS receivers because we didn't use RTK. We used post-processing kinematic because we use the trajectory coming from the L1 to be post-processed with the Rhinix data coming from the Leica GS10. And also, we had a couple of custom-built desktop workstations, and in the field we have HP Vectus. Those desktop workstations configurations was i9 with good RAM capability, not more than 64 or 128, and the laptops are normal gaming machines. You don't have to have an Alienware to be able to process such project. Also, people think that LiDAR processing is more consuming and more capable, so it need more capabilities, more capable computers compared to photogrammetry, but the opposite is correct, because photogrammetry is more demanding than LiDAR. But again, you need to select the right tools. Starting from week 3 to week 6 was the project, which was the 1st of August, I believe, until the end of August. But before the project, we had to scout for a week, and also we had to test for a week, because testing was crucial. I started to test to fly at 50 meters, at 70 meters, and at 100 meters, and understand about the deterioration, how much points per meter am I getting. Also, 1 pulses or 2 pulses or 3 pulses, because you can have 3 returns from the L1. On the other side, how much should be the maximum speed am I flying to maintain the accuracy and also maintain the point density. It was my first time to do a large scale project like this, and the tolerance of the project was the same and the tolerance of the sensor itself. So I have to be very cautious. That's why we did a lot of testing, and this testing also gave us more scouting, so we had better planning and we finished the project in time. In week 7, we had couple of days for some revisions, maybe less than 10% of the plots were repeated, because sometimes we lost the colorization because of the different altitudes. Altitude made less overlap, so we had to refly again. We used M3E to measure the height tools, and also we did a very interesting 3D model, a digital elevation model for some areas, to give it to the remote controller of the M300 to respect the terrain and adapt the terrain follow when there is high altitude differences, which means that in some areas it's very easy for you to create a digital elevation model using M3E or even M300 or M350 with P1. You can fly at a high altitude and make a low resolution digital elevation model, and then you can give it back to the drone itself to fly. And sometimes we rely on satellite images, but I don't, because they are not georeferenced, and especially when you are flying at lower altitudes and there is a lot of objects, just difference in the location could cause the crash, because when the drone is thinking it already missed the cliff, it could hit the cliff itself. Also, the GNSS surveying workflow, we projected everything to Egyptian transverse Mercator, and also we started to do this at the end of the project, because we are flying with UTM and WGS84, and at the end we started to process everything back into the Egyptian spatial reference systems, and then we stitched the point clouds with the ground control points, and we referred everything to this baseline, and even the plots which we did fly from GPS point 1 or 2 or 3 or 4 were with the same quality and the same precision of 2 and 6, because we used precise leveling. And also we did an interesting that we linked, or we prepared for linkage with with the true height from the port, because we are on the shoreline of Sokhna port, and it will be easy. We can easily get a true height to even if there is any tie points needed for any pipeline in the future. We used Leica equipment. And also here again illustrating more details about how did we use this workflow for ground control points in the beginning, but after this we decided to put it in the overlapping line between plots, so not only to make less ground control points but also to stitch them together, and by solving it with virtual reference systems or the Egyptian course, we got the right spatial reference system required by the client. And by the way, there is no geoid model in Egypt, so it is a little bit tricky to get your spatial coordinate system accurately. We had to consult our professors from surveying faculty of engineering in Shubra and also Ain Shams, and also some of military defense experts. The project playbook for this, the software playbook for this project was very interesting. We started with DJI Terra because we can do a lot, not only processing data coming from the L1, but also we can do classifications. And we started to host the process data and bring the puzzle all together on Bentley MicroStation, one of the best platforms in which you can open not billions of points without affecting. Also, Bentley MicroStation is the drafting background for TerraSolid. So you open Bentley MicroStation first and then minimize it and then open TerraSolid, which is an advanced LiDAR point cloud processing and classification software. And at the end, we ended up generating the digital elevation model and handling the spatial data, and the Berland XML delivery was done through the famous Esri ArcGIS Pro. So here the data came from the L1. You start with the data grouping, and also each point cloud, each detail should be each point cloud data set, and each Rhinex file should be accompanied by its log file to be able to get back if there is a problem, to make some accuracy tests, to remove some data if it's bad data, and then decide to redo it again, because it's very easily you can lose accuracy and precision if you get lost through your data. And then export the data on MicroStation. Some data classifications was already done on DJI Terra. By one click, you can do ground point cloud classification, which means that we can remove this whole power station by one click. There is the magic of DJI Terra. And also, it's friendly for beginners. You know, all LiDAR software might be able to do this, but not as easy as DJI Terra can do it. And especially after the latest upgrade and the introduction of DJI L2. You can see, by one click you can do this. Also, there is a value of the digital elevation models, because here from the point cloud, you cannot recognize the difference of height, but here you can see it very explicitly. Even here also the earthwork which had been done for this road, you cannot see it here, but you can see it explicitly here. So how to generate a digital elevation model from point cloud also, there is, this could be done very, very easily in DJI Terra. Of course, generate contour lines from point clouds. I would love to thank you all for attending this part of the webinar with me. Now I will leave the floor for Brad, and also don't forget to put your questions in the Q&A. We are very happy because we will have good time to answer them.
Thank you, Mr. Izzat, for the great introduction of the LiDAR projects. But as we all know, L1 is the previous generation product, and the latest model is L2. So what's the improvements? does L2 compare to L1? If we use L2 to do such a large project again, what changes will there be in terms of efficiency and other aspects? So next part, I will introduce the DJI Zenmuse L2, powerful range, elevated precision. This is the contents of my introduction. So first I will introduce the L2 products, and the second part is the post-processing software introduction, and at last I will share some case studies. Okay, let's get started. So this is DJI Zenmuse L2. So with a lot big improvements compared to the last generation. So with high accuracy, high efficiency, fast returns, long range, etc. But no worries, I will introduce them one by one. So first big updates is significantly improved the practical measure range. So I'm not talking about some theoretically distance or parameters. I'm just say that let's be practical. So if we want to achieve for 5 centimeters accuracy, now the recommended flying altitude can go high to 150 meters, compared to L1 in the past that only can go to 80 or 100 meters. So in this way, the high precision flight altitude has been increased by 50 to 90%. The second is we equipped with this sensor with a 100% self-developed LiDAR sensor. So with the condition that we fly at 150 meters high, with a flight speed 15 meters per second, so the vertical accuracy can go high to 4 centimeters. Compared to L1 in the past is only 20 centimeters. So in this part, the accuracy has been improved by 400%. And not to mention the point cloud thickness, now still has been improved a lot. L2 only have 5 meters point cloud thickness. So the thickness has been decreased by over 70%. And with the improvements of the LiDAR sensor, now the L2 has smaller beam size, which means less noise. So with less divergence provides smaller beam size. Now it's only 20% of the L1s at 100 meters away. So I have also attached the 2 pictures here in the bottom just to give you an idea how it looks like. So it's really very small. So in this way, it can significantly reduce the noise, and we will have more complete fine structure. I have also attached the 2 real cases in the right. So you can see we use L2 and L1 scanning the same power tower. And the dataset is very obvious. So if we using L2, we will have more complete, more fine structure. But with L1, some parts has already been blurred and mixed together. So L2 definitely will bring us more good point cloud quality. And L2 has updates with the returns. Now has 5 returns, which means stronger penetration. So cooperated with the smaller beam size, so we will have more points, ground points on the ground. So I have also attached the 2 real cases. You can see in this way, in this area, we're scanning with L2 and L1. So after the classification, we get the pure ground points. So L2, we have 92 points per square meters. But with L1, there's only 36. So you can see in this is really improved a lot, which will effectively miss the virus forestry operations. And we have equipped with this LiDAR sensor with a high precision IMU, which is also 100% self-developed. Now the post-processing accuracy with L2 is only 0.05 degrees. So in this part, the IMU accuracy has been improved by 200%, which means we will have more stable high precision core and more stable data quality. The IMU now does not need pre-warm up. It means after the drone is starting up, you can take off immediately. So no need to waiting on the ground for 3 or 4 minutes, just like in the past with L1. So now you can take off immediately. So in this way, it can save you a lot of time during the preparation. And not to mention, the calibration time has also been extended. Now it goes to 200 seconds without the need for inertial calibration, which will again extend the efficiency. L2 has 2 scanning methods, same as L1, which is repetitive and non-repetitive. So what does this mean? How it looks like? So I have attached 2 GIF photos in the bottom. You can see how it works in theoretically. But if you want to using for surveying and mapping, want high accuracy, then we recommend you using the repetitive scanning mode. But if your target is power line, power tower, forestry, etc., then non-repetitive mode is recommended. Okay, we have also equipped with this LiDAR sensor with a very powerful mapping camera, which has 4/3-inch CMOS, 20 million pixels, with mechanical shutter, 200,000 shutter lifespan. Now the shortest photo interval is going to 0.7 seconds, which means every 0.7 seconds you can take a picture. So in this way, it has been improved by over 300%. So since the camera speed, shutter speed has been improved, now the full flight speed can go high to 15 meters per second. So we have already introduced the IMUs does not need warm up. The distance goes to high to 150 meters. The shortest photo interval 0.7 seconds. And the flying speed can go high to 15 meters per second. So all these features combined together. So now with L2, for the single flight coverage, you can achieve 2.5 square kilometers for a single flight. Compared to the L1, so which means the operation efficiency has been increased by 5 times, which is really amazing. So is that if you're using L2 to the same project, wow, it will save you a lot of money. For example, in the past, you use L1, maybe spending like 1 month. Now, with maybe less than 1 week, you can finish the whole project, which of course will save you a lot of money, which is very powerful weapon for you. So besides this, we have also enhanced the user experience. So now with L2, we have a point cloud live view. So in this way, during the flight, you can see all the point cloud in real time on the controller screen. And after the drone is landing down, you can also see the point cloud library. So you can view the point cloud immediately in the album. We also provided the field work quality check. So after the drone is landing down, then we can check the data collection quality with RDK or RTB, things like that, just to be sure that all the data collected can be accepted. So with the newest release of firmware, so L2 now supporting the power line follow function, which means the system will automatically identify the power lines and flying above the power lines according to the parameter we set. So all this will be automatically done. So how it works. So let me using a real video show to you. So first, the system will identify the power lines. You can see the power line has been identified, and you just need to set in the parameters. So flying speed, flying altitude. I have also attached different parameters here in the bottom. Just based on your different scenarios, different need, you can set different parameters. Also the gimbal pitch angles. So after the parameter has been setting, then the system will carry out the mission automatically. So even there's a branch, so the system supports the junction selection, so you can choose which way to go. Okay, so the second part, let me introduce the post-processing software. We have equipped with L2 with a complete package with free software. So because L2 now already includes a DJI Terra license for point cloud data processing, including the pre-processing and post-processing for the point cloud function. So there's no software upgrade fee. So during the product lifecycle, even new point cloud functions will be permanently free of charge. So which does this mean? So for example, if you just need the pure point cloud, non-colorization, no 2D orthophoto, then there's no need for you to purchase a DJI Terra. You can directly using Terra to process the L2 data for pure point cloud. But if you want the colorized point cloud or using the photo taken by this camera to get a 2D or 3D model, then still a DJI Terra Pro version is needed, but not for pure point cloud. So, and with DJI Terra, so we can get very smooth point cloud because the point cloud thickness is prone to be too thick, which will affect our accuracy of the final results. So with this function, it can effectively fatten the point cloud. In this way, it can improve the accuracy of the final data. So I have attached a comparison here. So you can see the gray one is raw data, is raw point cloud, and the red one is the point cloud after smoothing. You can see the thickness has been increased a lot. Okay, there's another case. So you can see the raw point cloud thickness is 12 centimeters, and after smoothing, it only goes to 1 centimeters. So it really improves a lot. But our customer, they might think, well, they might worry about. So during the fatten, yes, the point cloud thickness is good, but will we losing some structure or will we losing the real shape of the targets? No worries, actually. We have considered about this. So I have a real case here. So you can see at the side of the road, there's a small slope. So after the smoothing, the slope is still there, but the point cloud thickness has been greatly improved. And let's go to more complicated scenarios. So you can see here, we have a roof top with wave shaped. So after the smoothing, so the shape is still there, not changing, but the point cloud thickness has been improved a lot. So this feature is really useful if we want to get some really detailed targets. And Terra is very easy to use. It is supporting the one-click point cloud processing with classification, generating the DM, and control lines. So we just need to enable these buttons, inputting some small parameters that we want, and then Terra will take care of the rest. And for the control lines, it supports different formats, just for us to easy to import to another third-party software. And with the newest release of DJI Terra, now actually there's a big update we call the fusion function. So it means the fusion of LiDAR point cloud and the photos for 3D mesh. So now the point cloud and the photos collected by L2, it can combine to generate the 3D mesh. So in this way, compared to the photogrammetry workflow, this fusion function, the workflow will be more faster and we will have more details of geometric. So I have prepared a real case that I really want to share with you. So this is a 3D mesh from the photogrammetry. You can see the power lines in the air has missing and this structure has been failed. Because it's really common in the photogrammetry workflow during the 3D reconstruction. These small structures are really easy to fail, and because during the data collection, so maybe the structure is too small, the GSD is not good enough, or maybe there's a sunlight reflection, so lots of reasons. So the fail of the 3D reconstruction is really common. But with fusion function, how it looks like. Wow, it's really improved a lot because you can see all the lines are there and the structure is complete. Why this has been improved a lot? Because the LiDAR point cloud has the coordinate. It can collect very complete data sets, and since each point has the coordinate, so in this function we are using the point clouds to get the structure and using the photos to give it the texture. So in this way we will have more complete structure. So you can see in these three pipeline are totally missing and failed in the photogrammetry workflow, but will be well captured and generated in the fusion workflow. And there's another structure you can see in the photogrammetry workflow is totally being deformed and blurred. And in the fusion function, it has good shaping and good looking. And I don't know whether you have noticed that these three power lines has been totally missing in the photogrammetry workflow. So if you have very complicated scenarios, you want to have very detailed targets, then using the fusion function, it's really useful. And since we have talked about the point cloud, so as we all know, I just want to extend a little bit. Because we all know in the photogrammetry workflow, we can also generate the point cloud. So Terra now has been expanded the application of the visible light products. So after the point cloud has been generated in the photogrammetry workflow, we can still do the point cloud classification, get the DM, get the contour line, or we can use the grid points to get the team model. And I have attached a real case that to give you an idea how it looks like. The brown one is a raw point cloud. So you can see it's very dense, lots of points. But usually sometimes we don't know so much points. So we can use the grid points to get these black points, has some regular distance, and then we can use these points to get the team model. And the model size, you can be larger or can be smaller, depending on your settings. It's really useful. So the third part, I will share some case studies. Okay, first, some of our attendees might wondering, wow, for L2, single flight coverage goes to 2.5 square kilometers, as we mentioned before. Is Brad kidding? Are you joking with me? No, actually, this is achievable. This is achievable. So let me using a real case to show to you. So first, I really want to thanks to my partner in China. So it's a case provider is Shanxi Wendatong. This is their logo. So from China, they did this case in last November. So it's a city park with extensive vegetation coverage, and they are flying at 150 meters high, just as we introduced. The side overlap 20%, and estimated duration goes to around 37 minutes, and the air coverage is actually 2.5 square kilometers. This is a real case. This is a real photo of the sites, and this is a screenshot of the controller. You can see although it's a Chinese version. I'm sorry, but this is a real case. This is a screenshot provided by our partner. So as if you are familiar with our controller with the interface, then you will know this is the flying altitude. Flying altitude, you can see 150 meters high, and the flying speed goes to full speed 15 meters per second. And you can see the average area coverage 2.5 square kilometers. Estimated flying time 36 minutes 56 seconds, approximately 37. Okay, so and this is a side overlap. Side overlap goes to 20%. And so let's see how is the mission be carried out. So we uploading the mission to the drone, and then the drone starting first to do the IMU calibration front and back for 3 times, and then the drone starts the mission. So this is a screen recording by their controller in actual case. So this is how it looks like during the mission is carried out. Yep. Okay, and let's do some post-processing in DJI Terra. So you can see this after the data has been processed, generated point cloud, and we can measure the area coverage in DJI Terra. So the projection area, it's kind of small. Okay, let's enlarge. Yes, you can see the projection area is 2.5 million. 2.5 million. Actually, it's 2.54. So which means 2.54 square kilometers. So that this is the area. This is a real case conducted by our partner in China. So yeah. So and some you might wondering. So in this real case, the side overlap is really small, only 20%. So will be the penetration effect be good enough? Okay, let's make some cross section of the forestry. Okay, you can see we mix some cross section here, and you can see there's still a lot of points on the ground. So let's change it to another position. Yes, very good penetration. Okay, another cross section here, so very good. And even on the side of the rows, so the tree may be smaller, and we will have a more complete of the tree's shape. So you can see it's really good. It's achievable. But just pay attention to, okay, their flying altitude is 150 meters high, and the battery is almost reaching its limitation. So, but during your actual project, please pay attention to your local flying regulations and during your actual flights. This is very important. This is just for your reference. But even you fly 120 meters high, but the efficiency will be way out a lot, improved a lot by the L1, definitely. Because of flying speed, you can fly very fast, and the higher, so you can have larger coverage. Yes, of course. So next case, let's see some forestry case. So this is so because when the customer they want to purchase a LiDAR sensor, so I guess the main reason is that they want to get the point cloud ground points under the trees. This is the main reason. Because if you are doing some road or some bare ground, you can use a photogrammetry. You can use Mavic 3E. That will be good enough. So okay, let's see the penetration. So we make I just providing the final results. Okay, so this is, let's make some cross section here, so you can see lots of ground points under the trees. So let's switch to another position. Yes, still very complete of the terrain of the hill. And another position, very good penetration. Okay, let's change to another position. Yeah, very complete of the ground points. So we can switch to any different position. You can see the penetration is very good. So okay, next case, let's share some power line inspection. So in this case, you can see, I don't know whether you noticed this or not, but this case goes to 1,000 voltage, which means 1 million voltage. It's a super high transmission power lines, which means this power tower is super high. So including the power head, the power tower total height goes to 110 or 120 meters high. So it's really tall. So during the actual mission, so the drone fly above, so it's easy for us to carry the first or second layer of the power lines because it's very easy to capture. But it's very hard for us to capture on the bottom. So it's very easy to losing the lines, to get breaking lines, losing the data. So but you can see in this case, we have very complete data sets. And after the classification, you can see the power lines is very complete. Okay, and let's make some cross section. You can see the power tower head is very complete, and even the small structures, very amazing. I have to say, I haven't seen this data set before. Really amazing. And let's make some cross section. Each small first 1, 2, 3, 4. So all the 4 layers we have a very complete collection. But some of our customer they might wondering, so what does these small points looks like? Okay, could we zoom in to see some details? Yes, of course. Why not? Okay, if we zoom in, okay, you can see actually these small points actually is combined by 8 different groups of points. Why does the point cloud look like this? How it looks like? Because actually the actual structure is looking like this in the left side. So because the actual structure, actual power lines is combined by 8 different groups. So which means we are not just collecting very complete power tower, but for the power lines, even the bottom of the power lines, we can collect them very good, very well. And okay, and the last case is the point cloud thickness. Some screenshot just to show you how it looks like. I'm not doing the background introduction, so just a quick introduction. Okay, so for the point cloud thickness here. So you can see, actually, the drone is flying in the air with different flying routes. So there might be connections between 2 flying routes. So actually, this blue lines is a drone flying route. So drone is flying. For example, the drone is flying like this, goes about and turn it around and flying back. Okay, so it means in the bottom here in the middle of this area. So this is a connection of two flights. We don't want there's a different layers. We don't want we want very complete, very smooth point cloud. So you can see I make a long cross section here, long cross section, and you can see the point cloud is very smooth, very continuously, no different layers. But if we want to see some details, so we can zoom in the middle of the here. We zoom in this part. Here you can see the point cloud is still very smoothing, no different layers, and the smaller grid represents 5 centimeters. 5 centimeters. It's really good. But if you want to still challenge me, so could we zoom in more? Yes, okay, let's zoom in. Okay, let's go. So for the very middle of the connection, so you can see this smaller grid represents 1 centimeters, 1 centimeter, and the point cloud is still very continuous, no different layers. So the red one, yellow one, so it has a very good connection. Not like this, right? So it means the point cloud thickness is within 2 centimeters. It's really amazing. So this is a real performance of DJI Zenmuse L2. So with very good penetration, very good efficiency, very good. We can collect very detailed structure like power tower, power lines, and a very good point cloud thickness. This is a real case, and I believe if you using L2, you can get the same data sets. So this is my part. So thanks for listening. So any questions? So please feel free to leave your comments or your questions in our dialogue section. Now the next part we are going to answering your questions live. So okay, let's see the questions.
So I will stop sharing the screen. So if you still have more questions, yes, I guess in the first beginning, I replied some questions, but since some questions is very complicated, so I just replied. I remember there is a Terra compared to Terra Solid. Yes, here maybe yes, I have also replied here. What's the difference between DJI Terra and Terra Solid? So basically, it's two different software, and Terra Solid is very good. It's very powerful. I have to admit it that. But Terra is very easy to use, especially for the beginners. So don't have so much buttons, so many menus you have to switch, you have to find. So if you just want just like the datasets we introduced today for the point cloud DM control lines, so it's really easy. So you don't need to spend like a month to learn. So just within half an hour, you can learn this software and using for the actual project. There's another. I'm sorry. So for the questions, and I guess there's another one for the. I'm sorry. Merge the point cloud. Yes, when merging point cloud from different chunks of processed, how do you join them without variation in elevation? Actually, how to say? There are several options. The first one is using the latest version of DJI Terra. Then the processing ability is super large. You can, for example, you can import all the flights together to process them together. In this way, when doing the processing, it can avoid or doing the flying route alignment to avoid the different layers. But if the, for example, the computer IM is not big enough, then you can using the GCP to control, just like Mr. Z doing. So use the GCP to control the point cloud. Then in this way, even they are processed by different projects, then the elevation is in the same standards. So many questions. So thank you for the hot discussion. So I will try to answer all the questions. Okay. And so Miss Lizette, so can you see the questions too?
No, you can send them to me, Brad, please. And on the other side, I can answer the last question, which you just answered. Yes, the two methods are valid, and the most realistic one is the second one because it will be great, especially if you have a large scale project. It will be very hard for you to process whole data at once. So you must have an overlap. So in my case, I had an overlap 50 meters, a buffer 50 meters on each side of the project. So it will end up by 100 meters from two sides between each plot and the other one. And the ground control point is falling in those 100 meters. Sometimes you cannot put it in the same edge. So it might go 10 meters right or 10 meters left according to the topology of the topography of the region. But again, it will still fall within the 50 meters buffer right and left. And then you can do this using the ground control points. And also, this was done on I don't know if it could be done in Terra DJI Terra or not. If not, it was done in Terra Solid in our case. So according to your project, according to your scale, in general, you should have a different path. That's why there is no best way. It's according to your situation. Brad, can you please read the questions?
Yes. Yes. So there's one more question, and same question, I guess. The scenarios when drawing layers from different trunks, they have a gap in overlap. For example, one is down and one is up. So how does we solving this? So for example, if we already have the point cloud with layers, so first we have to decide, we have to find which one is right. This one is right, then we have to switch this one down. So Terra actually has the function that you can adjust the elevation, but just input the numbers. So for example, you want to lower this for 10 centimeters, then you can just put minus 10 centimeters, then the point cloud will be adjusted. But if both two are wrong, the actual position is in the middle, then you can adjust them too using the GCP first to check which one is right, which one is the right position.
I have an input here because we need to know the source of this error from the very beginning. So it could be, you remember when we were speaking about that we use precise leveling because we are using different base stations for a big project. So we must understand first that the base station is, all base stations are on the same, let's say, datum. So they could be reflecting the same precision and accuracy. So this could be a reason. And how to solve this? Yes, through the ground control points and also through the overlap. Okay. Another thing for you to make sure that nothing happened and also to have a consistent point cloud density as well and accuracy, you should use terrain following in case you are flying at a low altitude. So using terrain follow will require a digital elevation model done by photogrammetry first.
Yes. Okay. Thank you. And there's another question. I guess it's very quick. So does the fly attitude matter in L1 data processing? Actually, for the data capture, so you can fly between 50 to 120. So the accuracy will be the same, and the quality, it will depends. If, for example, fly higher, it means the less points on the ground, but you can adjust with the flying speed or the overlap. So it's a complicated question. So, but the accuracy will be the same from 50 to 120 meters. It depends on the efficiency requirements of your projects. But on the data processing, yes. So, for example, Terra supposed for you to input the numbers from the lowest point or the, for example, if you fly 120, but if you import the numbers to 0 to 80, then the Terra will only generate the distance from the LiDAR sensor and within 80 meters. So it will not get longer than 80 meters. It means you will have no points on the ground. So just to be sure that the number we input is larger than the actual flights, because if you fly 120, maybe there's some gap on the ground, so the actual distance will be longer than 120. So maybe you can input 150 or 20 meters or 200 meters during the processing when you input in DJI Terra. Okay, I'll try to. So thank you for waiting me for so long. I'll try to answer all your questions. How possible is to with accuracy of the ground control points to fit the rich construction model? That's a good question. How possible is it to enable the accuracy of the ground control points to fit the construction model? Actually, I don't know whether you are asking for 3D or the point cloud, but both are can adjusted by the GCP. You can import the GCP to adjust the 3D model or the point cloud with the GCP. For example, if you are using the photogrammetry, get the 3D model, then you can import the GCP in the error triangulation part. Then the error triangulation results will be good, will be accurate. Then the 3D model will absolutely be good. I'm sorry, so many questions. Okay. Could you obtain the link for the YouTube? Yes. So after 4 hours, after this webinar, we will uploading this recorded video in YouTube. I'm really sorry for the misoperation from my side to break the webinar, but I'll try to fix it out. Okay, thank you. So since I didn't get a chance to since I don't get the chance to manually tag the GCP painted on the ground at the point surveyed in the LiDAR point cloud processing method, what should I do if my survey is horizontally shifted and I want the point cloud to be fitted both on? So I'm sorry for right now. So Terra only supports for the elevation correction, so we can adjust the elevation. But for the horizontally, unfortunately, I'm really sorry, Terra now don't support. But we are already have the plan. Maybe in next year in H1 we will release the new feature. But right now, if you want to adjust it now, so please using another third-party software. So maybe Terra Solid is the right option, to be honestly speaking. But we are trying to catch up. Check the sound quality. Okay. Okay. What's the term has an impact on it? Do you have any power? When do you active power line follow? So I'm sorry, I don't get this question. So because the power line follow function is with the latest version of L2, it's released in this July. So please update your firmware. Then you will find this function in the pilot app. What's the best accuracy one can get for elevation with L1 LiDAR? So maybe is that you can answer this question. What's the best accuracy one can get for elevation with L1 LiDAR based on your project experience?
It was 5 centimeters. And in general, in LiDAR, it is very strange that you can get sometimes the height elevation is more accurate. Okay, in general, we get vice versa from the GNSS, because in GNSS we get better positioning accuracies, while the height differences had maybe double the accuracy. But in LiDAR, it is vice versa. So according to our experience and according to this project, when we flew around 70 meters, we got 5 centimeters, plus or minus, of course. And again, you can thin this because one of the processing stages is to remove the overshoots and the undershoots. So at the end, you will only keep the healthy points which best fit the surface. And this is another layer, because processing of point cloud data is a very relative term, because processing stages could be various. So starting from classification, ending up with normalizing the data itself and making it more clean for you to use.
Okay, thank you. Okay, and there's another good question asking about the DRTK2. So I guess most of you using this, but yes, sorry for the design. So for example, so my mouse is RTK2 antenna, and this is the pole that we are using. So for example, we set it on the ground. So yes, so actually during the survey, actually the antenna is surveying the position here. So if we don't import the 1.8 meters, because the distance is fixed, is 1.8, but we don't import this number in pilot, then all the point cloud will calculated or processed based on this position in the air, not on the ground. So in this way, you will find all the point cloud is upper is high than the GCPs. So we can fix this in DJI Terra. So after you importing all the data, before starting, you can click on the base station function. There's a setting there. You can click and changing the base station height to reduce 1.8 meters. In this way, all the point cloud will be fit. Or you can using the GCP, using one GCP to drag all the point cloud lower. This is the option.
And there is normal for most of GNSS devices that you need to insert the height of an instrument. But because maybe the DJI Terra come with L2 and DJI M350 with the DRTK2, it's one bundle. So it might be already pre-decided. But again, the height of instrument is essential in most of surveying methodologies.
Yes. So I guess we have one last question. Shall we get the webinar attendees certificate from DJI or Geomatics? I'm sorry, I don't think we support this function. But many thanks for your participate our webinar. So maybe so is that so? Could you provide this for the webinar certification?
No problem. We can provide this, and also we can provide detailed answers for anyone who is still not very convinced or doesn't have our questions answered well. And we are glad to help you with your projects, even in the Middle East or outside the Middle East.
Yes. So Mr. Izzat, so could you leave your email address or so that our attendees can catch up. So if they have further questions.
My email address, I can show it here now. It's in the on top right part on our website. It's esabry@geomatics.com, esabry@geomatics.com, because I cannot type. So if you visit Geomatics, geomatex.com, you will find my email in the top right part, and also my mobile number. I'm very easy to access.
Yes, I have also attached your email address in the chat box, so everybody can see this. I guess yes. We have answered all the questions here, so I'm ready. Okay. Are you active in Qatar as well?
Yes, we can provide support in Qatar, and also if there is anything needed, we can help even with the local DJI reseller in Qatar.
Yes. So yes. So I guess this is it, and many thanks for your participation for today's webinar, and thanks Mr. Izzat for joining us to introduce these great projects. So we have leaving the contact information. So if you have any questions, or if you want these materials today we are introduced from my side or from Mr. Izzat, so please write a mail to Mr. Izzat. Then I can share my presentations, the case, and also all the information you need. So okay, thanks again, and let's keep in touch. So welcome to participate our future webinar. So hoping we can use DJI solution to greatly improve your working and less changing the surveying workflow together. Thank you. Thank you for your
Thank you.
participation.
Thank you, Brad. Thank you, everyone,
Thank you.
again.
Thank
And
you.
guys, you owe us another webinar. Also, maybe it will be for photogrammetry. So
Yes. Yes.
have a good day. Thank you. Bye bye.
Okay. Okay. Thank you. Thank you. Bye. Thank you.